This is a lecture on section 2.6, which is scatter plots and best fitting lines. Right away, we're going to have a decent amount of vocab that I want to cover, so go ahead and pause it here, write this down. I'm just going to continue talking about it. A scatter plot is a graph of a bunch of data pairings. We're going to have a bunch of XY points, and we're going to graph them all together. There's just going to be a bunch of dots, and we are going to be looking for trends of these scatter plots that we have. We say that our scatter plot has positive correlation as y would increase as x increases. So as x is increasing, your x value is going this way, the y value is going up. That would be positive correlation. And if y is going down as x increases, that would be negative correlation. Right? So as x increases, y is going down, negative. If as x increases, y is going up, that would be positive correlation. Our line of best fit, or our best fitting line, it might be called, is the line that lies as close as possible to all of the data points. There is actually a very formulaic way that we can do this using our graphing calculators, but there's also a way that we can approximate it by hand. All of that stuff should be review, but this term should be new to us, a correlation coefficient. This correlation coefficient will be designated by the letter R. And it is a number that ranges between -1 and 1 that measures how well our line of best fit measures the data. So let's talk about that for a second. So our correlation coefficient, or R value, will be somewhere between -1 and +1. 0 would say that there is no correlation. This is kind of a weird scale, so I want to write it down. An R value of 0 would say there is no correlation. You could not possibly draw a line of best fit because it wouldn't make sense. The data is just completely spaced out. Something like this, where you're like, well, I don't even know where I would draw the line of best fit. A correlation coefficient of 1 would indicate strong positive correlation. So what I mean by strong correlation is that all of the dots, all of the points that we've graphed, seem to make a very distinct line. That would be a strong correlation. Our line of best fit is a very good indicator of the actual data. And it's positive because our line of best fit would have a positive slope, or it's going up as the x value is increasing. On the other hand, an R value of -1 would still indicate strong correlation, but instead it's going to be strong negative correlation. So our line is still going to be close to all of the points that we have, but our line is going to be trending downward. As x is increasing, the line is going to be decreasing the y values. We are also going to be using two other R values. Basically, the questions that I ask, I might give you a graph, and I'm going to say, estimate the R value as either being close to -1 or -0.5 or 0 or +0.5 or 1. An R value of close to 0.5 would indicate moderate positive correlation. And an R value close to -0.5 would be moderate negative correlation. Both of these you could draw a line of best fit, but it's maybe not super accurate. And obviously, if it's going up, it's going to be a R value close to 0.5, and if our line is going down, it would be an R value close to -0.5. So first up, we've got some different indicators here. I just want you to tell me what type of correlation, positive, negative, or none. Our first graph here, if we were to draw a line of best fit, it would look something like that, perhaps. This is clearly negative correlation. And if I were to ask you what its R value would be close to, I would hope that you would come up with an R value, that's supposed to be an R value of about -0.5. Okay, it's not particularly strong correlation. Our line of best fit is not that great of an indicator of the way the points actually are, right? They're pretty spaced out, and it's going downward. This one, though, would be positive correlation, and this would be an R value of closer to +1 because our line of best fit is a much better indicator. It's not going to be probably all that close to 1, but it's still going to be closer to 1 than something like 0.5. And this one here looks like no correlation, and that would be an R value of close to 0. So that's one of the tasks that I'm going to have you do on your quizzes or tests would be to identify what type of correlation it is and approximate the R value. In addition to that, I'm going to have you draw a best fitting line or write the equation for a best fitting line. There are two different ways to do this. One is by hand, and one is using your calculator, and I'm going to go over both. It is very easy to use your calculator, and on your quiz, there is an expectation that you are able to use your calculator. But if you were to go by hand and approximate it, it is a lot of work, but it is doable. First step is if you're going by hand, is to draw the scatter plot. Step 2 would be to sketch a line that appears to closely resemble the most data points. This is your line of best fit. Okay, step 2 says draw the line of best fit, essentially. Step 3 says choose 2 points on that line. It's really important that you understand this part, though. They do not have to be points originally plotted. They do not have to be from the table. Okay, they're just points on your line and estimate those points. And then finally, you're going to write an equation that passes through those 2 points. In order to do this, you have to know how to write an equation if I give you 2 points. Okay, if I give you 2 points, you should be able to write an equation. This was from a previous lesson. I believe it was 2.4. First thing you would need to do is to use slope formula, find the slope, and then we should be able to write the equation. So let's go ahead and take a look at this. Here is our table. I've already gone ahead and plotted the points just for the sake of time. So step 1 says plot the points. Step 2 says draw the line of best fit. Maybe our line of best fit would be something like that. You're not playing connect the dots. You are trying to draw a line that has that's as close to the points as possible, and it should have about the same number above and the same number below. And then you are going to pick 2 points that the line goes as close to perfectly through as possible. And it's kind of good to have them a decent distance apart from one another. It's very close to going through this point here, -3, 5, as well as perhaps 4, -2. And now my task is to write an equation of the line that goes through those 2 points. In order to do this, we need to use slope formula, y2 minus y1 over x2 minus x1. -2 minus 5 over 4 minus -3. Right, we know how to do this, I hope. -2 minus 5 is -7, and 4 minus -3 is +7. So my slope is going to be -1. Once you know your slope, this is one of the ways we went over this, -1x plus b. So I put -1 in for my slope and y equals mx plus b. And then I'm going to pick one of the 2 points, and I don't care which one. And I'm going to plug the x value in for x and the y value in for y. -2 is equal to -1, 4 plus b. Multiply those and I get -4. Add 4 and I get a b value of 2. That's my y-intercept. And if I look here, it does look like it goes through 2. My equation then is -1x plus 2. That's going to be my approximation for the line of best fit. Now, I also want to try doing this using a calculator. And this is going to give us our actual answer, the real answer. And let's see how close we were with this line of best fit. In order to use our TI graphing calculator to approximate the line of best fit, this is actually considered like a statistics type question. So you're going to find what we need under statistics. And then at first you are going to go to edit, and you're going to actually select the edit button. So number one, you push one or the enter button here, and you're going to get some tables. And in these tables, you're going to enter all of the x values into L1. So -2, enter. -1, enter. 0, enter. 1, enter. 2, enter. 3, enter. 4, enter. 5, enter. I know this is very exciting. Now let's go over to the second list, and you're going to enter all of the y values in there. 4, enter. 3, 2.5, 2.5, -1, -2, -3. Notice that the L1 and the L2 have to be the same number of terms in them, or your calculator is going to give you an error. When you want to get rid of this information, because you will from time to time, if you want to get rid of one number, one entry, you can push the delete button there and it'll get rid of it. If you want to clear a whole list, you can go up and highlight the name of the list. Do not push delete here, because that'll actually just get rid of this whole column, and that's not what you want to do. You want to leave L2 there. Instead, you're going to push clear and then enter, and that will clear the contents of that list, but still leave the list. So it's kind of confusing. If you want to clear the whole list, push clear, enter. If you want to delete one entry, you can use delete. So I've got it all entered now, and I want to tell it to write the equation for the line of best fit. In order to do this, you're going to push stat again. And before we entered it under the edit button and we entered all the information, now we want to actually have it calculate the line of best fit. So you're going to choose calculate, and then you're going to go to number 4, which says lin reg ax plus b. You can either scroll down to 4, or you can push the 4 button on your calculator. You do want to get the x list from L1. The x values we entered in as L1, and the y values we entered in as L2. I'm going to go down to calculate. This will give me the line of best fit. The A value is -1.02, it looks like, and the B value we'll call 2.29. So our approximation was y equals -1x plus 2, and the actual line of best fit is -1.02x plus 2.29. So we were pretty close, but it wasn't exactly accurate. I will encourage you guys to make sure that we know how to use our graphing calculator for this, because some of the problems that we are doing are not going to be so easy to graph like this, like I had done for us. So let me know if you guys have any questions, and that is our lecture on scatter plots and lines of best fit.